All right, moving on to subtracting. Subtracting is actually the same exact as adding. Obviously, we're going to subtract instead of add. Only one small piece is going to be different, which is if the top numerator is smaller than the bottom numerator, you must borrow from the whole number. You're borrowing it as a fraction and you're adding it to the top fraction to get the new top fraction. This part can be very confusing. So I just recommend, if you get confused, find other YouTube videos on subtracting mixed numbers and fractions. Use your book, look at examples in the book, or just keep rewatching my video over and over again until maybe it sinks in for you. Feel free to email me with any questions, okay? So again, you're gonna get a common denominator, get your new numerators. This time we're gonna subtract, keep the same denominator. When you subtract, it won't come out improper, so that's good. Subtract your whole numbers and reduce if you can. All right, let's do a couple of these. All right, so the first two, I kept them simple. I gave you ones with the same denominators. So all we have to do is subtract our numerators. 9 minus 3 is 6 over 11. That cannot be reduced, so that one is done. Next one, I keep my 8, subtract my 7 minus 3, which is 4. Divide these both by 4 because they can be reduced. They're both even. You can divide by 2 or 4. 4 means we only have to do it in one step. 4 divided by 4 is 1. 8 divided by 4 is 2. Okay. Next one, since I don't have common denominators, I'm going to line them up one on top of the other. I'm going to look for a common denominator. I look at my largest one first. Can 5 go into 10? Yes, it can. So let's use 10. This doesn't expand, it stays the same. But this one down here expands by 2 because 5 times 2 is 10 and 1 times 2 is 2. Subtract. 9 minus 2 is 7. Keep the 10. And 7 minus 1 is 6. This cannot be reduced, so that one is done. Okay, next one. I have different denominators, so I'm going to do one on top of the other. Okay, I need a common denominator of 5 and 4. So if you think of your highest number 5 and at all of its multiples, 5, 10, 15, 20, 25, 30, 35, what is one that 4 can go into? And it would be 20. You could also have just multiplied 5 times 4. Okay. This expands by 4 because 5 times 4 is 20, so 1 times 4 is 4. 4 times 5 is 20, so 3 times 5 is 15. Okay, here is a subtraction problem that is going to require some borrowing. So let's look at this for a second. Let's say that I had 22 minus 16. When you can't take 6 away from 2, we have to borrow to make that a 12. But we have to do the same thing with fractions. We have to borrow to make that top fraction bigger, okay? This needs to become bigger so we can subtract 15. So this is how you do it. We're going to subtract 1 from the 10 and make it a 9. When you subtract from the 10 and make it a 9, you're going to bring the 1 that you borrowed over here, and you're going to change it into fraction form. So we took the 1 that we borrowed from here, and we're moving it over here, but we're going to write it as a fraction. That fraction has to equal 1 whole. So what we're going to do is we're going to look at the denominator that we have. The whole point of adding and subtracting fractions is you have to have a common denominator. So I'm going to use the same denominator. Because why would I change this denominator? I would have to go back and redo all my denominators. So keep it all the same. So what is my top number that I can use that will make this equal 1 whole? Well, that answer is 20. 20 divided by 20 is 1. So there's the 1 that you borrowed. So the 1 that we borrowed is 20 over 20. But we already had 4/20ths there, so now we have a total of 24/20ths. Now you want to leave it in proper because you need this big enough to subtract your 15. So now I can do 24 minus 15, which is 9. Keep the same denominator, and 9 minus 3 is 6. Cannot be reduced. That one is done.